Good afternoon and welcome to the live webinar on My Mission Admission, your gateway to your dream career, course and college. In today's webinar, we're going to talk about air photography. Unique, isn't it? This unique and interesting course is a part of Roorkee Engineering and Management Technology Institute, REMTECH. They have developed India's first Java-based acoustic radar. This gives photographs of air, and they say the way we look at our own body through an ultrasound machine, similarly we can also see air. And this is the theme of today's webinar, air photography. To discuss about this course, we have with us Dr. H.N. Datta. Good afternoon, sir.
Thank you. Good afternoon, everybody.
And Dr. Datta has a vast experience of 40 years and is an expert in acoustic radar. And sir, this topic is equally new to me as it is to our dear audience. So without much ado, let me pass on the screen to you and let us begin with our topic then.
Thank you. Good afternoon, everybody. It's a pleasure for me to be part of a web seminar. This is the first experience through which I am going. I really do not know what kind of interaction ultimately we will have. Try my level best to let you know what exactly is meant by air photography. So let me start through the slides. Air photography, naturally, nature has gifted us eyes. We see the entire universe through our own eyes.
Excuse me, sir. Have you started with the screen share? We cannot see the slides on.
Okay, the slide is not coming. Just kindly wait.
Sir.
Okay, kindly wait. अच्छा शेयर करना ओनली यहाँ ऑप्शन आ रहा है
It has started now, sir.
No, but how do we अच्छा okay, now this one. हाँ वही तो करना है sharing करना है ना share this share yes ma'am, are you able to see the slide?
Yes sir.
So we start our discussion about the air photography. Air photography or the entire photography is inspired because nature has gifted us our beautiful eyes, and it is through these eyes that we really see the whole world. Nature has gifted us eyes, and through these eyes we see millions of objects in nature. We recognize some of these objects by name, by their uses, by their applications, etc. We see these objects light, optical light, which is generated by the sun, and this light falls on various surfaces, is scattered from these surfaces. Like my own face is a surface. A small portion of this scattered light comes towards our own eyes, and through this small feeble part of light processes to see the objects and recognize them. The light coming to our eyes contains information about the texture of the object, its dimensions, movement, etc. And our mind is capable of determining many other features like happiness, the face, etc. Since all this has been gifted by nature, we hardly recognize the importance of light in life. It is absolutely dark, and we have to work in this darkness for a long period. For your kind information, close to Antarctica, and there you have absolute and now we can see the interior of our body even through an ultrasound machine. In these techniques, although we use wavelengths which can't be seen, like X-ray we cannot see with our own eyes, but making use of X-rays to see the interior of our body. Similarly, we use what we call as the ultrasound, and we convert these images into an optical image so that we are able to realize the state of bones or tissues, etc. Now we can see through IR cameras, we can see our own human body through IR cameras, and the pictures are absolutely interesting. Now this is the image of a person through a normal, what is called visual or optical image, and similarly we have the same person viewed through a thermal camera or IR camera, and so this is the thermal image. Actually, the wavelength of light is so...
Sorry, sir, to interrupt you, but the slides are not moving further. I mean, it's stuck on the first slide.
Okay, the slides are not moving.
No,
Okay,
sir.
okay, okay. Are देखना slides are not moving. Okay, अच्छा अच्छा.
Now it has come, sir.
Now it has come.
Yes, sir.
Acha, okay. So maybe I will have to use it like this. So this, so let me slightly go back. I mean, if people have really not followed. See the optical image, we are seeing through the light is the thermal image of the same person. In light, the reflection takes place from the uppermost surface, and in thermal image is the highest possible temperature from where the image has to really emerge, and the camera will then convert it into a thermal image which can be seen by our own eyes. Now in the infrared picture, although we see a human body as clear as we see in the usual light, it will require us to realize what is called pattern recognition. Suppose we are seeing each other through an infrared camera or through an X-ray, then we will have to have a pattern recognition. We are easily recognizing each other through the optical camera because since our birth, we are absolutely confident of recognizing the patterns or realizing the patterns. So pattern recognition requires a professional training, and it is only due to this importance that we require a radiologist to recognize the images. This is the thermal image. At the airport, a camera is installed. If somebody is suffering from a high fever, the infrared intensity will be higher, and immediately one will be able to point out, yes, you are suffering from a higher fever. The person will never be in a position to know, yes, it is swine flu. It's only to popularize the machine. This machine is being sold as a swine flu detection machine, but it is basically an IR camera installed at the airport to isolate people, those who are having a fever. This is the photograph taken through an X-ray, and the second one is through the what is called the gamma ray, so that you can see even the interior. In case of ultrasonics, these are mechanical waves, and when these waves are sent into the interior of our body, naturally they will get reflected, like sound gets reflected from objects or from bodies. So ultrasonic will also get reflected from various tissues or other foreign materials or bones present in our own body. So this part shows, the what is called the kidney stone in the tissues of the kidney, and the expert will be in a position to measure even the dimensions. Yes, there is a kidney stone. Exactly in the similar fashion, because today ultrasonics everybody knows. So in my case, in the case of ultrasonics, we are transmitting pulse of sound, or what we call as ultrasonic sound, into the interior of our body. In my case, I am transmitting a powerful pulse of sound into the atmosphere. And once this pulse will go up into the atmosphere, it will interact with the molecules present in the atmosphere. And in air, air is never absolutely homogeneous. It has perturbations in terms of temperature gradients, as well as velocity gradients and the density variations. So the density variations in nature or in air fluctuations or temperature fluctuations present in the atmosphere. So we transmit a powerful pulse of sound, say 100 watts of acoustical energy, of electrical energy, and what we receive is about 10 to the minus 12 watt or 10 to the power minus 14 watt. And to realize it, this is what we do. This is the actual photograph of an antenna. So the antenna is a parabolic fiberglass dish, like we receive the signals from the satellites. So this dish has a commercially available what is called unit or a transducer, which will convert electrical energy into acoustical energy, so that we'll be in a position to illuminate the atmosphere right from surface up to a height of 1 kilometer. And then the scattered energy from the top will come, and this energy will be received by the same transmitter or the transducer. I'll just show you the actual photograph. So we have this is the instrument that we have installed at the Roorkee Engineering and Management Institute. So the antenna is inside this dome, what is called the acoustical dome. It will absorb all the noises which are prevalent or present at the site. So the antenna is sitting inside like this. The antenna is sitting somewhere here, and in that we have pasted 4-inch thick foam, so that whenever we are transmitting the signal, we are transmitting signal right in the vertical direction. My air is right up to say several kilometers above the antenna. I don't want my energy to go in this direction or in that direction, so that there will be reflections. That part I don't want. So what we will do is, so we transmit and then receive. This particularly, the entire equipment, a computer and a software that has been specifically developed by the students using a Java-based software, and it will process the whole signals. Now, what the most important part is, what exactly we see in terms of as far as the photograph is concerned. Because when I say I'm seeing your own photograph, normally I mean that I am seeing an optical photograph, and that is how our nature be able to appreciate. But if I am, suppose you are seeing your thermal image, then I will have to realize, yes, the thermal image is there, and then I will have to go for what is called a pattern recognition. I will have to change my mindset. This is what we see. We transmit a pulse, pip. It's a very loud pip, because it's a 10-watt acoustical energy or 100 watts of electrical energy. So this pip will go up into the air. As it moves up, it gets scattered from the thermal perturbations present in the atmosphere. So line by line scanning, after every 6 seconds, line scanning will give me a scan or a photograph, a line photograph of the air. Because air is never at rest, it is always moving. So with the result, with the passage of time, I will have a three-dimensional view of the what is called the atmospheric dynamics. What do we know? The question is this: it's very simple to take a photograph. This is the height, and this is the time axis. Say 1 hour. It shows some kind of a picture, and a person like me, like a radiologist, is required to read the X-ray. So I am basically from the field of acoustic radar, about 40 years of experience in giving the interpretation to what exactly is meant by this photograph or these photographs. So this photograph shows the passage of a fog layer. See, sitting on the ground, I will never know what is the upper boundary of the fog. So in my instrument, to see, yes, there is a fog layer which is extending right from surface up to a height of about 800 meters. And even in that fog layer, the very dense fog was below about 300 meters. Then the density was slightly decreasing, and finally the in the upper region of about 800, the fog has ended. So we know the dynamics. I know that at this time the fog was only 400 meters thick. So sitting on the ground, we could have never imagined that yes, I am able to see the upper boundary of the fog. Now let us look at this particular part. Transmit the signal, it goes up for 3 seconds, and the scattered energy also comes back in another 3 seconds. So it takes 6 seconds for my pulse to go from surface up to a height of 1 kilometer and the scattered energy to come back. So therefore, that is the reason to now in 6 seconds, we think that we are, now what do we really see in terms of this picture? This picture is very beautiful, it is able to convey. But what exactly we see? We see that in the backscattering, suppose we have thermometers, two closely placed, spaced thermometers, say T1, T2, T3 like that, and they are all separated by a distance of just 2.5 meters. Separated by a distance of 2.5 meter, that means in a height of 1 kilometer, 400 such thermometers we have installed. The difference of temperature between two thermometers, we have to square it, and that will contribute towards the strength of my signal. That means because it is a square, my sound will not distinguish whether the temperature is decreasing or increasing. For this, the intensity of scattering will be the same. But it is my own interpretation that I will be able to give you in this particular slide. You see in this particular slide that there is a column, a broad column on the ground, and inverted cones are there, and this is moving up. Cone is moving up. So it is a daytime temperature. The temperature, because it is sunny, so the temperature on the surface of Earth is much higher compared to the temperature of air at a height of 1 kilometer or 2 kilometers. With the result, what we see is thermal convection. The hot air parcels from the surface moving up and the cold air mass from the top coming down. Portion is the homogeneous cold air from this upper surface coming down, and the black part is the warmer air moving up. Now, once this is happening, we know that whatever we are going to liberate on the surface of Earth because of our vehicular pollution, or we are cooking, or the pollutants emitted from factories, they will be all carried up into a larger volume of the atmosphere by these thermal currents. And so therefore, once we are planning, say in a city like Delhi, cars, okay, but if the cars are running at a time when we are having thermal convection, then the air pollution will not stay on the surface of the earth. It will be carried up and mixed into a very large volume. The intensity will be very, or what we call as the pollution density will be low, because as we move up, the winds are of very high velocity and they will carry the pollutants from the source of their production. On contrary, if we look at this picture, there are layers. See what happens in the night, the temperature of air close to the surface of earth is much lower, because in the night the temperature has decreased, and because the temperature has decreased, which is close to the ground, its temperature has gone down, while the air mass, which is at a height of a kilometer or 500 meter, its temperature is still higher. We say that these are called inversions because we have inverted the sign of temperature. In the daytime, temperature was decreasing. In the night time, the height up to which the temperature will increase is called the surface-based inversion, or it is an inversion. Now, what happens in an inversion? Because the temperature of this air is lower, so it cannot move up. It is much heavier than the air aloft or air present over here. So now at this stage, whatever air pollution or we are going to liberate, it will remain suppressed by these layers. So in the night time, whatever pollutants we are going to liberate, and if these inversions are present, they will not allow any vertical churning. The pollutants will have to move horizontal direction along the direction of the movement of the wind, and therefore the pollution density will be much higher. You see that the thermal convection is there, and suddenly there is a layer in the upper regions. There are multiple layers. Under such circumstances, the pollutants are going to be, there is going to be a buildup, and serious issues related to air pollution will be there. You can see the thermal inversion. That the thermal inversion, the thickness is about 400 meter, but even in this thickness, there is another layer present, and that is at a height of 300 meter. So these are very serious issues or episodes as far as air photographs are giving us the indication.
What do they depict? The third and fourth?
Yeah, that's what I was going to say. What do they depict? You see, when the pressure is higher, when the atmospheric pressure is higher, the whole air starts compressing, is compressed towards the ground. And when the whole air gets compressed or is being compressed, you will have multiple such layers, because it will stop the vertical movement or the vertical churning. Times when you will feel so much of suffocation in air because there is no fresh air available to us. In Shamli, this particular graph we were operating, there was suddenly a thunderstorm, and one can see that this is the portion. Now, this portion is during the night time. In night time, if there is a thunderstorm, that means in the upper regions, the cooling is taking place. So with the result, the temperature gradient, the lower surface becomes much warmer compared to the air here, and we suddenly see the movement, vertical movement up, and we can say yes, there is going to be some unusual phenomenon that there was a thunderstorm. So therefore, this particular technique, it not only gives me photographs of air, it also gives me the atmospheric dynamics. I should be in a position to find the reasons what exactly is causing these photographs, and that's what is the main study as far as these photographs are concerned. It's a very beautiful, wonderful photograph. See what happens in the night time. Nature forms inversion. Inversion means the temperature of the air on the lower side is much lower compared to the temperature here. So we have an inversion. Now the heating will take place. Slowly the atmosphere is getting heated. The thickness of this layer is increasing, and you can see that this thickness becomes about 640 meter, and then it vanishes. So although the sunrise could be at about 7:30, 6 o'clock in the morning, give me exactly the precisely at what time the inversion had vanished, or inversion had uh, has been killed or by the thermal convection. And afterwards you will see, you will have thermal convection. That means the inversion, since it's a natural process, it requires a lot of energy for it to be destroyed. And till it is not destroyed, we cannot say yes, the atmosphere is fully convective. Once atmosphere is fully convective, then whatever amount of pollution you want to liberate, you can liberate. Secondly, suppose my thickness of inversion is 150 meter, and if I have to install factory where the pollutants have to be liberated, then my factory, the chimney height must be above the inversion height. And that is what, and for many our super thermal power plants, they have to study this what is called the atmosphere for 1 year, and then decide height. And chimney height has to be certainly much above the thickness of the inversion. If chimney is here, then naturally whatever they are going to liberate, it will not affect the people on the ground. These are some other photographs. I mean, very complex phenomenon is there. You see, as far as Mother Nature is concerned, in a similar fashion all over the globe, say about for about 90% of the time, after all, you have sunrise, you have sunset, you have a midday and all that. But 5% features are such that they are specifically seen at that particular site only. And that's where lies the whole bread and butter. We have to give interpretation. We have to explain what is the cause and what are the phenomena which are really responsible for causing those for photographs, or rendering those photographs to appear on our screen. If we really see this particular photograph, it's a wonderful photograph because the surface layer had crossed our limit, and then it has decreased. So these kinds of, again, the thunderstorm development activity was there, and one can see the entire dynamics. And I'm sure you are enjoying this particular part. For those who are interested in to know what exactly happens, so we have to transmit. PR is the power that we are transmitting. PT is the power that we receive. C tau by 2. C is the velocity of sound, that is 330 meter per second. Tau is the pulse length. Pip. So I transmit a pip for 50 milliseconds. So 50 millisecond is my scale, or the transmitted pulse that will move in the atmosphere as a tracer. And AE is the antenna area, a 4 feet parabolic dish. R is the range. So as the range increases, my intensity decreases by the square of that. Of course, is the absorption. It is because of this absorption that we have to really decide what kind of a frequency has to be there. And on the basis, this is a very simple equation. and its realization, the whole thing has to be realized in terms of what is called the technology. The software has to suit to what we all calling that we are transmitting, say, 10 watts of power. So we require a transducer which should be able to handle that kind of a power. We receive 10 to the power minus 12 watt or minus 14 watts of electrical power. So that transducer must be able to sensitive to take care of those signals. And then of course amplification, filtration, and all those things are there. So we have applications. We have applications of atmospheric dynamics, air pollution, air-sea interaction, earthquake precursors. I have taken a patent, international patent, that on the basis of these air photographs, we should be in a position to give a warning, what is called the not forecast. We should be in a position to see a precursor of an earthquake. So these are many of these applications are there. And then if somebody certainly needs it, we can provide this radar. It has many applications. So thanks a lot. And for details, one can certainly log at my mission at admission.com for further details. Thank you. Thank you very much.
Thank you, sir. That was a wonderful, wonderful webinar. And although I myself have so many doubts, but you know, it's such a thing for me also, and I'm sure for the students also. But you have certainly explained us very well, and you know, given us a new light about this topic.
Thank you.
So I'm sure the students will have enjoyed it, and you know, I would really like to know about a little bit maybe about the earthquake precursors that you were talking about. You know,
yeah.
Other things I a little bit, you know, understood. The students would have understood a little bit because it's a vast thing. They need to study it completely to understand it fully. But it was wonderful. I'd just like to know a little bit about earthquake precursor that you were just talking about.
See, question is, I'm seeing you for the first time, isn't it?
Yes, sir.
But from the optical light that is getting reflected from your face, I can realize that you are about 25-year-old. Really a nice girl. Okay. So all this is hidden in the light that is getting reflected. Okay. What happens that before the rupture of the earthquake, the main event, a very feeble amount of energy gets liberated from the area where the earthquake is really going to explode or earthquake is going to strike. Okay. It is this feeble amount of energy, when it comes to the air, it's a big amount, because the mass of Earth is 10 to the power 24 kg. Compared to that, the mass of air is only 10 to the power 18 kg. Air is million times lighter compared to the Earth, Mother Earth. So even if billionth part of the energy leaks through, it is a huge change. And that is what I had exploited in taking an international patent. India holds only one international patent related to earthquake precursor, and that is the credit comes to me. Okay. Someday we can always organize a seminar on precursors of earthquake, because that's a topic which has to be really understood and discussed. Yeah. Because the air is so light.
Right, right.
But the problem of air is, see, look at me. If I have to draw a line here, I have already drawn. It is very easy to draw a line. Already got dissipated because the molecules, they merge together again. So therefore, I need a watchdog like my acoustic radar, which is scanning the air, which is taking the photograph of the air after every 10 seconds. So this is the fastest and the cheapest possible equipment available in the world to measure the parameters photographic display. See, photographic display has billions and billions of qualities. See, if suppose somebody gives all your hair, that this is the color of this hair, this is the color of this hair, puts you in what is called in n number of what is called horizontal and vertical pixels, to construct those pixels and draw your picture. So a picture tells billions and billions of things in a much simpler fashion, and that is what is the purpose of air photography. If somebody would like to come, because we are giving training on this particular equipment to our students. Many students are coming to understand the whole electronics, because it is a part of their radar and signal processing, and then of course signal processing in terms of computer science, electronics, and all those things, plus the interpretation of the pictures. So if any student will be interested, we will be certainly at their what is called service, because after all of you belong to us, our nation, our great nation. Thank you.
This particular course training is a part of another engineering, field stream.
Yeah, surely, because 4 days we are imparting a complete capsule of training just for 4 days, and in 4 days a person will be absolutely confident. Of course, as far as pattern recognition is concerned, are zero, because Mother Nature is creating so many different what is called patterns, that it is not that easy. Okay, thank you.
Someone expert like you will be able to explain to the students.
No, not at all.
It was wonderful talking to you, sir, and I'm sure the students will have enjoyed it so much, and so have I, because it was really new for me also. Thank you so much for your time, and
thank you, thank you very much. But I do apologize for what all had happened before I started my lecture, because of what is called we are in a remote place, and the speed of net is a problem here. Thank you very much.
Wonderfully, sir. Thank you so much. Thank you, audience, for viewing our webinar, and stay tuned for more such webinars. And thank you, sir, for depicting. Thank you.